Now that you're comfortable with straight lines, we're going to move on to our next function. And this one is called a parabola. Some people call it a quadratic function as well, and you'll notice that it's got a squared in it, like our quadratic equations. So let's look at the very basic parabola of y equals x squared, or if x is equal to x squared. So the first thing we can do, just so that we can gauge a shape to it, is do our old school method of using a table. So I'm going to substitute in where x is equal to -2, and I get that y is equal to 4. I'll do the same for -1, and I get that y is equal to 1. Then similarly for 0, I get 0. Similarly for 1, I'm going to get 1. And then if I substitute in x equals 2, I'm going to get 4. So the next step is to plot these points. I'm going to start with the point -2, 4, and there it is. And then -1, 1, 0, 0, 1, 0, and 2, 4. All we need to do is connect the dots. Now, just be warned, you're not going to connect the dots using a ruler. You're going to create the general shape so that it looks something like this. So now let's discuss what we see here in terms of this graph. Notice that I've also labeled it because we want to create good habits. So let's have a look at some of the characteristics of this graph. The first one that I notice is that it's U-shaped. All right, and then I can also see that the y and x intercepts are at the point 0, 0, and I've just made a note of that at the bottom. Now I see that the graph is decreasing on this side. By that I mean if I look from left to right, it's going from up top to down at the bottom. So it's decreasing. But then on the right-hand side, I see that it's increasing. Because it's gone from decreasing to increasing, something must be happening at this point here. We call this point, and very important, the turning point. It's where it's turned from going down to going back up. So I've written down there that the turning point here is at the point 0, 0, or the origin. Turning point is going to become a very important phrase, and it's going to come up pretty often with parabolas. Next, I can see that it's symmetrical about the x-axis. Now, what on earth does symmetrical mean? Thank you, Google. It means that it's made up of exactly similar parts facing each other or around an axis. So if I folded it in half, it would basically be a mirror image. The way we say this mathematically is that the axis of symmetry is x equals 0, meaning that if I folded it across x equals 0, I would get an exact copy of the graph on both sides. Let's see what the internet has to say about the definition of the axis of symmetry, which is also a very important concept in functions. Here we see that it's a line through a shape so that each side is a mirror image. When the shape is folded in half along the axis of symmetry, then the two halves match up. So that was x squared specifically. Now let's talk about the general equation, or the standard form for general parabolas. In grade 10, our standard form is y equals ax squared plus q. What I want to do now is break down the standard equation so that we can see what impact each portion had. Just like we did with straight line graphs, we figured out what impact the gradient had, or what impact the y-intercept had. Here, we're going to figure out what impact this A and this Q have on this graph. So let's start with A. This is going to tell us about the shape of the graph. The best way to consider this is to start plotting different graphs. So I've started here with gx, which is equal to 2x squared. So you'll notice fx was 1x squared, and our gx is 2x squared. From this, we can see that it's a pretty similar shape, but it's a little bit narrower. Let's have a look at the x-intercepts and y-intercepts. Well, those are still at 0, 0, and the turning point is also still at 0, 0, so no change there. So let's have a look at hx, which is a half x squared. Well, there we can see that the x-intercept and y-intercept are still 0, 0. The turning point is also 0, 0, but this graph is wider. What we can understand from this is that the smaller the a value, the wider the parabola, and the bigger the a value, the narrower the parabola. All right, so that works when we're dealing with positive a values. Let's consider a negative a value. Well, okay, so this is jx, this is negative x squared, and now we can see that a negative has flipped this upside down. Let's have a quick look at the intercepts and see what we can see. x-intercept and y-intercept still the same, and the turning point is still the same. So the only thing that has changed is the direction of our u. In fact, we can generalize and say that when a is greater than 0 or positive, we will always have an upward facing u. I like to call that our smiley face. When we're positive, we're smiling. And in general, when a is less than 0 or negative, we're going to get a downward facing or a sad face. So when we're positive, we're smiling. When we're negative, we're sad. So now we've seen the impact that a has on the parabola. Let's have a look at what happens if we change q. So I'm going to start by making q plus 2. So now we have the graph x squared plus 2. It looks pretty similar to the original graph, except that it looks like it's been shifted up by 2 places. So let's see what that means for the x-intercept. Well, if you look really carefully, you'll see that now the x-intercept doesn't exist. This graph doesn't ever cut the x-axis, so there are no x-intercepts. Also, we can now see that the y-intercept, instead of being 0, 0, is at 0, positive 2, and so is the turning point. It's pretty interesting. Let's have a look at one more. Let's look at x squared minus 2. Now, if we look at this, we see that this is just the original graph shifted down 2 places. Notice that it isn't widening or narrowing, it's just shifting up or down. Now we see that there are 2 x-intercepts because it's now cutting the x-axis in 2 different places. Our y-intercept is now at 0, negative 2, and so is our turning point. So what can we gauge from this? Well, q shows us our vertical shift. It shows us how much we're shifting the graph up and down by, or, and this is only for grade 10, it is also your y-intercept value. If q is greater than 0, like in kx, we see that this means it shifted the graph up. And if q is less than 0, like in mx, this means that it shifted the graph down. So that is how a and q impact our parabolas. Let's just revise. A impacts the shape. Is it a happy face or is it a sad face? And q impacts the vertical shift, how much it moves up or down from the original x squared graph. Let's do an example. This example says, sketch the graph of y equals negative 2x squared plus 8. Since I'm sketching, I'm going to need a grid, so let's just have that on hand. And then it's going to be important that I know what is my a value and what is my q value. So here I can see a is negative 2 and q is 8. Step 1, let's look at the value of a. Because it is less than 0, I know that that means my graph should be a sad face. So just like in the straight line when we used our gradient to give us an idea of the general shape, here we're going to use the a value to give us a general shape of the parabola. Step 2 is going to be finding our y-intercept. Now, if you remember correctly from our previous one, this is pretty linked to our q value of 8. So x is equal to 0 at all of our y-intercepts. So the y-intercept is at the point 0, 8. And I'm going to plot that on my graph right there. The next step is going to be to find our x-intercept or x-intercepts depending on our graph. So let's have a look here. To find our x-intercept, we're always going to set y equal to 0. So wherever we see a y, we're going to replace it with a 0. Now I'm going to move this negative 2x squared over, and I'm going to get 2x squared is equal to 8. I'm going to divide both sides by 2, and I'll get x squared is equal to 4. Now, please be careful. Before you want to jump the gun and say that x is equal to 2, please remember that x is equal to plus or minus the square root of 4. So that means that x is equal to positive 2 or negative 2. Remember, negative 2 all squared is 4, and positive 2 all squared is 4. So we have 2 possible numbers that will give us a value of 4 when being squared. So now I'm going to plot x equals 2 and x equals minus 2 on my graph. And the very next step is just to draw it in. Now we need to remember that it's a sad face, so if we connect the dots nicely, it should be a sad face. And there it is. Okay, guys, that's what you need to know as your introduction to the parabola.